Assalamu alaikum students. I hope you all are fine. I'm here with your lesson of chemistry, and this is for grade 9, and that was the lesson that was being taught during the last week in the online classes. So all those students, those who have missed these classes, please see this video and try to understand the concept or the topic or the topics which are studied over the week. It is Boyle's law and this is chemistry. My dear, firstly we need to understand that what is Boyle's law. So it is very easy to understand that Boyle's law is named after a scientist who presented this law. And what was the name of that scientist? Robert Boyle. What? Robert Boyle was a scientist who presented this law. And when was it presented? And that was presented in 1662. Okay, now you see, first part of this topic is introduction, and in introduction please see here on the board, introduction. In 1662 Robert Boyle studied the relationship between the volume and pressure of a gas at a constant temperature. Robert Boyle was a natural philosopher, chemist, physicist and inventor. He is famous for his Boyle's law. So easy to understand, but there is one thing that I need to explain to you. What was the concept about? This concept, my dear, was about the relationship between volume of gas. What is volume? Volume is the space occupied by a matter or anything. That means if you have a cylinder, of 20 kg, if you pour like 10 kg gas into it, so the whole cylinder would be filled. But if you apply pressure on that cylinder, you can pour in 10 kg more gas. Okay, so that means the gase's volume is compressible, it's adjustable, as we have seen in the properties of gases as well, like diffusion, fusion, compressibility, mobility, and all that depends usually on the larger distance present between the molecules of gases. Okay, so what was Boyle's law? What will it tell us? It will tell us about the relationship between pressure and volume, and that relation, my dear, is inverse relation. What type of relation? Inverse. Inverse means when you increase one thing, the other thing should be decreased. For example, let's say this is a rod or a stick. I'm applying a pressure on it. When I apply a pressure on it, its volume or size should increase. But in fact, it's decreasing. I'm applying a pressure, it's decreasing. That means one thing is increasing, that is pressure, but the volume is decreasing. That means in this case, this relation is said to be inverse relation. But if it be the other case, that I increase pressure, the volume is being increased. So that means one thing is increasing, the other thing is also increasing, and that means that this relation is said to be directly proportional or proportional. And you know, this is how it is. What is the statement about the Boyle's law? That he observed, he wrote, the volume of a given mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. Now, my dear, here you need to understand what do you mean by provided. Usually in English, the word provided means someone has given you something. But in science, when you come across a phrase like that, provided means by keeping, okay, by keeping. So when it says provided the temperature remains constant, that means by keeping the temperature constant. Now another phenomena or another concept, constant, if you are not scientific, you have no idea what is constant. Constant means same. So that means this is your cylinder. In this, the gas is poured. Firstly, fixed mass of gas. That means, let's say half kg gas. So then you are not going to increase the amount of gas. So then it is fixed amounts of gas. Then underneath, let's say temperature is 60 degrees centigrade. So you are not going to change the temperature. Temperature will remain 60 degrees centigrade. That means it's constant. So when things became constant, two things. Firstly, the mass of a gas, that is fixed and constant, and secondly you also have fix the temperature, so that means temperature also become constant. So now you can easily judge that when you will increase pressure, the volume will reduce. When you will decrease, you will make the pressure less, so that means volume will rise up, that means volume will increase. So what type of relation is that? That is inverse relation. First heading is introduction, second is statement, that is statement number 1, because there would come a second statement as well. Thirdly, mathematical expression, that is like important in science, how to describe the things mathematically, either it be physics or be chemistry. According to this law, the volume is represented by V of a given mass of a gas. Given mass of a gas, fixed mass of a gas, decreases with the increase of pressure P. So that means volume is presented by P, pressure is presented by P. Okay, so that means what type of relation is that one thing is increasing, that means if you increase the pressure, the volume will decrease. Inverse relation, and vice versa, etc. It can be written as V. This is V, stands for volume. Proportionality, this is sign of proportionality, and it is inverse proportional or inversely proportional, so that's what it would be 1 by P. That is equal to, if you remove the proportionality constant, so put the sign of equal, and then you use K here for proportionality constant. Then by multiplying P on both sides, how will it go? Like P multiplied by V, P also multiplied by K by P. So here P will be crossed. P will be crossed. Here what is remained? K only. So P will multiply by V on this side. So what the equation becomes is P into V is equal to K. Here K is the proportionality constant. We use for proportionality constant, and what are the things that we kept constant? For given mass of gas, we kept temperature constant. And we know that if mass is fixed and if temperature remains constant, so that means what will happen, that the value or the product of volume and the pressure, that means if you multiply volume by pressure, you change volume to any extent, to change pressure to any extent, whatever the changes will occur, if mass is fixed for the gas and temperature remains constant, so that means the product will remain same, it is not going to change. That is the focal point. And its value, here I have to write it, okay, and its value remains same for the given amount of mass of a gas. That means if you have a fixed mass of gas and if you keep the temperature constant, then the value of constant remains same. That means if it is P1, V1, pressure 1, volume 1, you change the pressure, it became P2. The volume will also change, that will become P2. But if the temperature and the mass of gas remains constant, so that means the product of volume and pressure at any stage will remain same. We will see that through experimental verification as well. So what is the statement then of the Boyle's law? This is also called a definition. The product of pressure and volume of a fixed mass of a gas is constant at a constant temperature. I already told you that if the temperature and the mass of a gas remains constant, so that means the product, if you multiply volume by pressure, that will be the product of volume and pressure. So that will remain same. So in case of P1, V1, it is equal to K. And P2, V2 will also be K, because the temperature is constant. So value, here we learn that value of constant remains same. It is written and its value, it's here K is the proportionality constant and its value remains the same for the given amount of mass of a gas. That means if mass of gas is fixed, then temperature is constant. So that means whenever you will find the constant, what is constant equal to? Constant is equal to P into V. That means pressure multiplied by volume. So that means whenever you will multiply pressure to volume for a fixed mass of gas, the answer, that means K's value should be same. And we will see that it can be described as then P1, V1 as the value of K remains same for P1, P2, P3, P5, whatever you take. So then that means we can say P1 into V1 is equal to P2, V2. Now, hence this is proved. When P1 V1 is equal to P2 V2. Why? Because the value of K is same. Either it's P1 V1, it's equal to K. If it's P2 V2, it's equal to K. So the value of K is same. So that means you can say that like P1 V1 is equal to P2 V2. Okay. Hence prove Boyle's law. That what is that Boyle's law? The product of pressure and volume of a fixed mass of gas remains constant at a constant temperature. That is the first part of the question. That is a long question as well as short question as a Boyle's law. Now